Hi and welcome to Prototype. We'll be solving the problem for LeetCode 121, best time to buy and sell stock. This is another problem in the LeetCode 75 study plan. Let's get to it. You are given an array prices where prices of I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, then return 0. In the example, they give an array with 6 elements, and it wants us to output 5 in this element of 715364. And the idea is that we would buy on day 2 when the price is 1 and sell on day 5 when the price is 6. The profit is 6 minus 1, which is 5. And they also note that you cannot buy on day 2 and sell on day 1. So buy when the price is 1 and sell when the price is 7, because you must buy before you sell. Okay. If you knew nothing at all, we could brute force it. Let's just get that out of the way real quick. So let profit equal to 0. How would we brute force it? We would have I equals 0, I less than prices dot length, I plus plus, and I keeps track of the buy price, and then j would be initialized to I plus 1. J would also be less than prices dot length, and then j would also increment plus plus, and the current profit would be prices j minus prices I. And if the current profit is greater than profit, then set the profit. And return. Okay, so that would be the big O of n squared solution. Obviously no good. So how do we do better? Well, it turns out we can just keep track of the minimum price. And we can initialize that to the first element in the array. We know that there's always going to be at least one element. And we can initialize profit to 0. And again, we'll be looping through all the elements. So for let I equals 0, I less than prices dot length, I plus plus. Keep track of the min price. How do we do that? So current price is prices of I. And if the current price is less than the minimum price, then set the minimum price to the new minimum price. All right. And we want to calculate profit. How do we do that? Well, it's going to be the current price minus the minimum price. And if that's greater than the profit that we've already calculated, then set profit to the new profit. So current price minus min price. Okay. At the very end, we'll return profit. Now, intuitively, let's think about this for a second. If the price decreases, could you ever make more profit when the price decreases? Think about that again. If the price decreases, could you ever make more profit than the profit you've already calculated? And the answer is no. Basically, if the price falls, to maximize profit, you would have sold it yesterday, or you would have already sold it. You would have sold it previously. So in the sense, we can kind of get rid of useless work, right? So let's say const price decreased is equal to prices of I minus prices of I minus 1. And also we can actually initialize our for loop to the second element because we're just setting the min price to the first element in the array. So we can actually just start at second. So we don't have to deal with any checks here. Okay, so again, if the price decreased, right, we can just continue. There's no need to calculate the profit if the price decreased, because the profit was already maximal before. It was already, if you could have sold it yesterday for a better price than today, you would have just sold it yesterday. So in that sense, we can kind of ignore the rest of what's going on. Now, what's happening up here? Well, the idea is that if there was an opportunity to buy at a lower price, so let's say we decide we're selling on day 3, we're selling at 5, right? We could have bought at 7 or we could have bought at 1. If we want to maximize profit, then we would have bought at 1. Then we would buy at 1 because it's the minimum price. If you had the opportunity to buy lower, you would have bought lower, right? So if we were selling at 6, well, we could have bought at 7, 1, 5, 3, or sorry, 7, 1, 5, or 3. And obviously, to have the greatest profit, the greatest difference, we would have bought on day 2. So that's why we're keeping track of the minimum price. Now, one other thing, if the current price is less than the minimum price, that means the price decreased. So we can actually continue. How do I know the price decreased? Well, we're at a price that's lower than we've ever seen it before. So it had to have decreased. No matter what the price was before, it had to have decreased to this new lowest price ever. Okay. So this is the same logic here. If the price decreased, we can continue. Now we can run this. What's going on here? Put 0. Oh, yeah, okay. The price decreased if it's less than 0. There we go. Okay, yeah. So that passed. Now, it turns out that we don't need this check. We don't need this check because it's, it's doing the same thing here, right? So this is the same amount of work, taking 2 numbers and then subtracting them and then comparing them to another number. So we don't need this. This actually handles that check with the same amount of work. And we have to calculate the profit anyway. We calculate the profit by current price minus minimum price. Now, of course, if this was an expensive call, then we could keep this here, right? And then this would save some effort, whatever effort would have been used to do this block of code. But we don't need it. This handles the same thing. The profit will only ever be set if the new current profit is larger than the old profit. So we can just leave it like that and submit it. There we go. Of course, because it's LeetCode, now it says we're only going to be 36%. Why don't we just give it another shot at submitting it again? And it beats 99.83%. Good old LeetCode. Okay. So this is the solution to LeetCode 121. Best time to buy and sell stock. Subscribe to see more. We'll be doing the rest of the LeetCode 75 study plan. Thank you, and see you next time.